Welcome to the WAGAS Innovation Talks. This podcast offers you an insight into recent innovations in the tech business, driven by research and industry insight. We are talking to researchers and professionals to share their expertise, experience, and projects with us. As a think tank and accelerator, we support tech startups and corporations in growing their business. We believe innovation is key to growth and hope to shine light on academic research and experts with real-life industry experience. To learn more, visit wagas-group.com and find all our podcast episodes plus articles and resources to expand your horizon on tech innovations. My name is Livia van Herde, Marketing and Sales Manager at WAGAS, and today we had the honor to welcome Boaz Almog to the podcast. Boaz has a varied business background. After graduating from university in physics and computer science from the Hebrew University of Jerusalem, he went on to become a quantum physicist at the University of Tel Aviv. He put his skills to good use, first as Quality Analyst for Backweb Technologies, and later he took a position as software engineer for that same company. Boaz then channeled his nearly 15 years of experience to establish his own enterprise, Brixo Smart Toys, which was in operation for 2 years. Most recently, he is CEO and founder of the Quantum Experience based in Tel Aviv, where he establishes himself as an instructor and innovator. On top of that, he has given a TED Talk about quantum levitation in 2012. Welcome to the podcast, Boaz.
Thank you. I'm happy to be here.
Today's episode is about quantum physics, superconductivity, and what we can expect from physics in the future. You're an entrepreneur and a physicist and an educator. To your first question, could you explain how did quantum physics in the past century help our society's technological progress?
Wow. Yeah. So quantum physics, I think, although we can't really see it, is very, very present in our everyday lives because every latest technology that uses semiconductors, microchips, memory chips, LED screens, all use materials that can only be explained and engineered using quantum physics. So it's very present, and the fact that people don't know that it's there, I think it's something that needs to be changed. And you know, quantum physics was discovered 100 years ago, more or less. So it's been here for many years, and it's well understood. So this is something that we need to change in terms of people's acknowledgement of this physical theory. And I can give you a few examples if you want of technologies. So
That would be great.
And in principle, if we think about quantum physics, we think about a theory that explains the physics of short distances, sometimes high energies, and short periods of times, which basically means atoms and materials and molecules and chemical reactions. And it turns out that in order to understand and explain how material behaves and how we can create new material, new objects with atoms, we need to understand the quantum nature of atoms. And so I think in the last 100 years or so, people have constructed a set of rules, which is basically what quantum physics is. It's a better understanding of how material in the nano level behaves. And it affects even our everyday life and everyday behavior. And this is when physicists start sensing that classical physics is not enough. When they looked at examples like how uh, how electricity and light interact, how heating and electromagnetic waves behaves. All these are examples where classical physics is not enough. So,
Yeah.
and they needed a new set of rules, so to speak. And this is what quantum physics basically is.
All right, so you already explained what quantum physics are, and which would be a second question. Do you have anything to add to that, or should we jump to the third one?
Um, I think maybe it's worth mentioning the
Hmm.
few basic principles of quantum physics.
Yeah.
And I think the first one to be discovered is the fact that everything, and specifically energy, is quantized.
Hmm.
And this was actually discovered or made as an assumption, and if you assume that the energy is quantized meaning that it can only get specific values. And if you look at any object, it can't really get any energy that we want when we think of when we try to describe its behavior. And when we
Hmm.
start adding this quantization, start things starts um, to to behave like they do in real life. And this was the first rule, that everything is quantized on a microscopic level.
Hmm.
um, the second thing is the fact that everything in nature can be described using a wave function. And this is something
Okay.
very, very intrinsic in quantum physics, where we describe objects as having wave-like properties. So it's
Hmm.
something that's completely unintuitive for people, for us, because we live in a classical world. When we think of particles, and when we think of particles, we mean that they have mass and velocity and coordinate.
Yeah.
But in quantum physics, everything is also a wave.
Hmm.
So we think of a wave as having an amplitude and a phase. And when we have waves, we think about interference, which means that the phase can add between two waves, and we'll have constructive or destructive interference. And once we get all these unique features, then we can start think about unique physical properties. And I think that's when the magic happens. That's where we start having new physics and new behavior, which is non-intuitive for us.
Hmm.
Um, and I think that superconductors, which I'll talk in a second, are
Yeah.
an excellent example of how quantum physics gives us behavior which is completely non-intuitive and cannot be explained using classical physics.
Yeah. So you mentioned superconductivity. Do you want to explain what that is?
Yes,
Hmm.
so superconductivity is something that has been around more than 100
Hmm.
years, um, and basically superconductors are materials, a family of
Hmm.
materials that conduct electricity without any losses. And it seems like a very easy thing to say, but it's not, because when you think about classical physics, the world around us, anytime we do some sort of action, anytime we transfer energy from one kind to the other. For example, in cars, when we have chemical energy
Hmm.
transferred into kinetic energy, we lose some of the energy to heat.
Hmm.
We excite some of the atoms around us, and we produce heat. But in order to have a system, a physical system where you don't have any losses, it has to be very, very unique. It has to be a quantum system. And that's exactly what superconductors are. They are a kind of material that quantum physics are the only way to explain their behavior. And The way that superconductors work it's very simple. You have a material where all the electrons inside the material lies in one single energy level. And it turns out in these materials that there are no other readily available energy states. So the electrons are forced to stay in that specific energy level. Remember, this is quantum physics, so everything is quantized. And in these materials, it's not just quantized, it's also engineered so there are no other energy levels. So the result is that you can transfer current in these materials without losing energy, because losing energy meaning giving energy and getting energy in return. So transferring to different energy states. And this property by itself give rise to very unique other properties like levitation, like quantum locking, the 3D locking of the superconductor in a surrounding magnetic field. So we start with quantization of energy, and we go up to levitation and magnetic fields and so on.
And why is this important? And can you also give us some use cases?
Yeah. So superconductors, first of all, they are not just important, they're super interesting because, as I said, they have all sorts of properties that could give us really, really unique technologies that we couldn't do without them. Just, to mention a few are MRI machines. For example, if we want to drive huge amount of currents in order to have strong magnetic fields, and strong magnetic fields can be used, for example, in MRI machine to probe the microscopic structure of our bodies, then we need to drive high currents without heating. And you can't really do that with copper wires. So you need a superconductor. So superconductors open the possibilities of creating magnetic fields. And right now we can have MRI machines, but in the future, because we can produce huge magnetic fields, we can do all sorts of new stuff, new technology with this ability. And of course, we can transfer energy. Imagine you have, the Earth is getting sunshine and energy from the sun 24 hours. Imagine you can transfer this energy to the dark side 24/7 all the time without energy loss.
Crazy.
It could change, it could change the energy balance all around the world. And there are many other things where superconductors have impact. For example, quantum computing. Because superconductors are quantum objects by nature, we're able to create technologies like quantum computing, where you have the basic information bit is not classical, it's not 0 or 1, but it's a wave function, like in quantum physics. Then you get all sorts of new possibilities and new capabilities that you don't have today. And maybe lastly, I would mention, but of course there are many more, it's the levitation. Because superconductors, because they have the material itself has this unique tool in his hand, right? It can drive currents without any energy loss. Then it can basically levitate itself in magnetic fields. And the levitation is not just levitation, it's a 3D locking of the material in a surrounding magnetic field. And of course, it could be used to levitate objects and to drive objects in high speeds. People talk about hyperloops. The that moves very, very quickly without friction, and this can be done easily with superconductors, for example.
Oh, okay, I see. Wow, now I'm sure you've sparked everyone's interest, everyone who's hearing this. And do you have any advice on how we can explain quantum physics to children, to everyone who wants to teach this to their children or children in
Yeah.
their family?
So first of all, I think all the things that I mentioned right now, all the new technologies, some of them are in development, some of them are will be developed in the future. All of these are technologies that grown-ups who grew up in a classical world, who were educated using Newtonian classical physics, all of these we devised, the grown-ups
Yeah.
of today. And I think if we educated kids from very early stage and gave them insights, the new intuition to quantum physics, then the things they will develop when they are grown up will be much more advanced, much more sophisticated. They will think of things that we can not even imagine today. So that's super important. The question is very, very critical, I think, to the future. Now, if you ask me how do we teach quantum physics to kids, then I think the answer is very simple. The same way you teach classical physics to small kids, and you do it very simply, not by showing them equations, not by talking about math, about rules, nothing like that. You just, for example, if you want to teach kids about magnets, what do? You give them magnets. You start exploring how
Yeah.
the attraction works, how the expulsion. You start playing with the physics. The same thing about electric circuits. So, and the same goes for quantum physics. You need to give kids experiments and objects to play with. So they start exploring, they start thinking about the possibilities. What are the rules that dictates the behavior of such objects? And this is what we do is, in our company. This is what quantum experience does. We put quantum physics and quantum levitation in the hands of elementary school kids, and we start talking with them about how this levitation rises from the basic principles of quantum physics. For example, we show them how the levitation works, and then we take a superconductor and we just put a compass around it. And what you see is, you see that the compass really freaks out because of all the currents that are flowing inside. And then the kids start to imagine that there are currents inside that's moving all the time and there's no energy loss. So they immediately start thinking about, maybe we can use it to store energy. Maybe we can create things with that. So it's quite easy with kids. Just let them play with it and talk to them about it, and that's it. They develop the intuition.
Very straightforward.
Yeah.
Now, we've already talked a bit about the future, and obviously, children are our future as well. What will be the major revolutions for society using superconductivity or any technologies derived from quantum physics? What do you think?
So I think in the last, let's say, 5-10 years or so, there have been a lot of advancement in material science, where a lot of effort has been done along the years to get or to design, engineer materials, superconductor materials that superconduct in room temperature. And if we had a superconductor, maybe I didn't mention it, but so far today, in order to trigger superconductivity in the materials, you need to cool them down. So we need to cool them down today with liquid nitrogen, which is, it's cheap, it's available, but it's cold. And we don't want to play with liquid nitrogen more than we have to. And if we could have superconductors that superconduct at room temperature, this would make them widely available and easy to use, easy to manipulate. So a lot of effort has been done to find and engineer superconductors that superconduct at room temperature. And in the last 5 years, there has been a huge advancement. And there are materials today that superconduct even above room temperature, a few degrees above room temperature.
Mm-hmm.
So this is going to be a major deal breaker in superconductors once we find the right materials that superconduct above room temperature. And the implications in terms of technology are enormous. So the first one and the obvious one is energy.
Mm-hmm.
You could transfer energy. Just imagine huge solar fields in one place, transferring all the energy to other places. Just, you can start, imagining how, for example, Africa, which has a lot of sunshine and a lot of solar energy, is made the energy source for the entire world, for example, or transferring energy from space to Earth.
Wow.
Each time you want to transfer energy without energy losses, you turn to superconductors. So this is a major issue. A second, I think, technology that is going to change our world around is quantum computing. I mentioned this briefly before. Regular standard computers today are operating on a classical operation principle, right? They either have voltage or not, 0 or 1. But if the basic element of a computer is a quantum element, which has a wave function, it has an amplitude, it has a phase, then you can start doing manipulations which are much more sophisticated and has the capability to perform much, much, much better than computers today. And we already start seeing quantum computers that operate in such a way. So this is definitely the future. And of course, the world of medicine. Just imagine having small, affordable, portable MRI machines in every clinic. Just imagine how well medicine will be, how better medicine will be once we have this probing capabilities in the hands of every doctor. It's gonna revolutionize the local medicine. And these are just few examples.
Yeah, that sounds very exciting. Amazing. Well, we've reached the end of our podcast episode. Thank you so much for your insight, Boaz. That was very exciting and interesting.
Thank you. It's my pleasure.
You can read more at wagas-group.com. This has been your Innovation Talks podcast produced by Livia van Herde. Make sure to check back next month for the latest insight in innovation.